Welcome back to AI interview questions series for Java developers. In previous video, we discussed Spring AI, chat client, prompts, and Java integration with LLMs. Today, we will cover one of the hottest interview topics, RAG, Retrieval-Augmented Generation. We will understand how RAG works internally, why it's needed, how documents are processed, how embeddings are created, and how Spring AI retrieves relevant information before sending a prompt to the LLM. What is RAG? RAG stands for Retrieval Augmented Generation. Instead of depending only on the knowledge already present inside an LLM, RAG allows the application to retrieve relevant information from external documents and provide that information to the model before generating an answer. Imagine a company has thousands of internal documents. These documents are never part of the LLM's training. Without RAG, the model cannot answer questions about those documents. With RAG, the application first searches the company's documents, retrieves the relevant ones, and then sends them along with the user's question. This makes the answer more accurate and based on company specific information. Why do we need RAG? LLMs are trained on massive datasets, but they do not automatically know your organization's latest information. For example, imagine a company updates its HR policy. The LLM has never seen that document. If an employee asks how many work from home days are allowed, the LLM may guess or provide outdated information. With RAG, the application retrieves the latest HR policy and includes it in the prompt. Now the LLM answers using the latest company document instead of relying only on its training data. What happens during document ingestion? Document ingestion is the preparation phase of a RAG system. First, documents such as PDFs, Word files, or web pages are collected. Large documents are divided into smaller chunks because LLMs and embedding models work better with smaller piece of text. Each chunk is then converted into an embedding, a numerical vector representing its meaning. Finally, those embeddings are stored in a vector database. This process usually happens once when documents are uploaded or updated. Why are documents split into chunks? Suppose we have a 200-page PDF. Creating one embedding for the entire document is not useful. If the user asks about only one paragraph, the embedding for the whole document is too broad. Instead, we divide the document into smaller chunks, such as 300 to 500 words. Each chunk receives its own embedding. When a user asks a question, the system retrieves only the relevant chunks. This improves search quality and also reduces the amount of text sent to the LLM. What is an embedding model? An embedding model converts text into numerical vectors. Unlike a chat model, an embedding model does not generate answers. Its job is to represent the meaning of text mathematically. For example, Spring Boot tutorial and Learn Spring Boot will have vectors that are close together because they have similar meanings. Those vectors are stored in the vector database and later used for similarity search. How does similarity search work? When a user asks a question, the application first converts the question into an embedding. The vector database compares the embedding with all stored document embeddings. Instead of matching keywords, it compares mathematical similarity. The most similar chunks are returned. These chunks become the context for the LLM. This is why semantic search is much smarter than traditional keyword search. How does Spring AI support RAG? Spring AI provides built-in support for many RAG components. It can work with embedding models to create document embeddings. It supports vector stores where embedding are stored. It can retrieve relevant documents based on similarity search. Finally, chat client combines the user's question with the retrieved context and sends everything to the LLM. Spring AI allows developers to build a complete RAG pipeline without writing every integration from scratch. Explain the complete RAG flow. This is one of the most common interview questions. And let's understand the complete flow. First, company documents are collected. These documents are split into smaller chunks. Each chunk is converted into an embedding. The embeddings are stored in a vector database. Now the user asks a question. The question is converted into an embedding. The vector database performs similarity search and retrieves the most relevant chunks. Those chunks are added to the prompt. Finally, the LLM generates an answer using both the user's question and the retrieved context. This entire process is called Retrieval-Augmented Generation. Why is RAG better than sending all documents to the LLM? Imagine a company has 50,000 documents. Sending all of them to the LLM for every user question is impossible. It would exceed the model's context window, increase cost, slow down response time, and include a lot of irrelevant information. RAG solves this problem by retrieving only the most relevant chunks before calling the LLM. This makes the system faster, cheaper, and more accurate. Today, we covered the core concepts of retrieval augmented generation. We learned why RAG is needed, how documents are ingested, why chunking is important, how embeddings model work, how similarity search retrieves relevant information, and how Spring AI helps build RAG applications. In next video, we will continue with questions 57 to 64. We will focus on vector databases, including PG vector, pinecone, chroma, milvus, indexing, metadata filtering, and similarity metrics. These are very common interview topics for developers working on AI and RAG applications. Thank you for watching. We'll see you in next video.